Hi, what happens when a light physically crashes into the matter like a billiard ball? So, this question actually addresses the particle nature of the light. Now, the two experiments which show this behavior are the Compton effect and the photoelectric effect. So, we will identify not only what happens with the energy and the wavelength of the photon after the collision, but either it's a Compton and or the photoelectric. So, this question categorically mentions about the scattering of the photon after the collision with a stationary electron. So imagine that this is the photon that have a so much energy that's why I will draw a very small wavelength of that photon, and it is traveling towards an electron which is at rest. So it is stationary. Now, this photon can be only the photon of X rays. And why I'm saying it with so much confidence, because in the photoelectric effect, whenever a light within this range from the infrared to the ultraviolet, and all the visible lights are automatically included in this range. So, any light within this group, when this light shines on a metal surface, so the photon of that light, it ejects one electron at one time. So why this happens? So because all the energy of that photon is completely given to the electron, and the photon vanishes. Photon is no more. It has given 100% of its energy to the electron. That happens in a photoelectric effect. So I'm sure now it is easy to identify that this photon should be of X-ray, because it have a more energy than ultraviolet, and this process is obviously a Compton effect. So the wavelength of this photon is lambda, whereas the energy of this incident photon is EI is equals to hc over lambda. Since the wavelength is so small, that's why the energy of this incident photon is so large. So when it will hit the electron, as you see in the second diagram, right now what happens, the drastically energy increases of electron, and electron recoils, I mean electron moves in some other direction, like this, according to the Compton effect experiment. So which, whereas photon does not deliver 100% of energy, unlike the photoelectric effect, it scatters. So how does it scatters? It scatter with a longer wavelength. So if it has a longer wavelength, means this is the energy of the scattered photon, which is hc over lambda s. Since you see that the scattered wavelength is more than the incident wavelength, which means that the scattered photon's energy is less than the photon's in incident photon energy. So it is scattered with a less energy, whereas it have a high energy. So what we conclude after this discussion, that energy of the scattered photon must be less than the energy of the incident photon, right? Whereas since the energy is inversely proportional to wavelength, so its wavelength must be greater than the wavelength of incident photon. So that's why the right answer is option D,